Okay, Assalamualaikum warahmatullahi wabarakatuh. So the last one, so we already go through in detail on the phases, type of the chromatography and a little bit on the calculation. The last one is regarding the theory of separation. So basically the theory of separation, so I will share the video from the YouTube, which is the animation one that I found that is quite easy to understand. Okay, but of course if we are having any problem on this one, so we can go through again next week during our lecture. Okay, so basically when we talk about the theory of separation ni, so there will be two theory. The first one is the one that I already explained previously, which is regarding the N, which is the plate number. Like I already mentioned, when we talk about the plate number, so this is the first theory, okay, that the researcher coming out when they are dealing with the chromatography, which is N is equal to L over H. Okay, when we try to obtain higher N, which is higher separation, so we have to make sure H will be lower. Okay, so after a few years, because the researcher find out that the plate number theory is very difficult, okay, to guess, to make an assumption on the separation. So that's why later the rate theory is coming. Okay, even though there will be N, there will be an equation, the one that you already learned previously, the one that you have to calculate the plate number, but also the rate theory is quite applicable nowadays. Okay, so rate theory is, we talk about the Van Damter equation, so don't worry, there will be no calculation for the Van Damter equation because most of them are constant. Okay, A, B, C are constant. But the one that you have to really understand is the theory. Okay, if this question is coming out in the exam, so usually you have to explain based on the theory. Okay, so you have to remember and also, of course, you make sure that you really understand. When we talk about the Van Damter equation, so it starts with H. Our aim is to make sure H is always lower to get higher separation. Okay, so that's why this, we call it as the equation, is quite similar to this one. In this equation, we also want to make sure H is always low to get high plate number, high separation. It same goes to here. Okay, to maintain lower H, okay, why we have to maintain lower H? Because when we are having high H, so usually the peak obtained is broad. Okay, so what does it mean peak obtained is broad? So you know that you have the chromatogram. When we talk about the broad, it's something like this. This is the one that we want to avoid. Okay, because we always want to make sure that our peak is very narrow. So that's why we can say that the resolution is higher. The peak will be, we call it as a well separated. Okay, but if H is higher, so the probability to get the peak broad is higher. Okay, so there are a few, we call it as a parameter that contribute to the higher H. Okay, which is A, B, and also C. Again, this is based on the theory. Okay, there will be no calculation involved for this one. Okay, so to maintain lower H, of course, you have to make sure that A here is lower. Okay, B here is lower, C is always lower, for example. Okay, so I will play a video so you can directly listen to the video from the YouTube. Okay. Okay, so let's watch the video together. Okay, so you can go through again and again on that video, but of course during our class next week, I will try to discuss a few questions regarding the rate theory. Okay, so I think that's all for this video. So thank you very much for watching the video. So we will proceed to another topic, which is HPLC and also GC.